There we go. Okay, now we are. Hello.
Hey, world. Well, according to that church bell, it is now 2:30 on a Wednesday afternoon here at Arcane Strategies, and we are going to do our weekly podcast recording. On the line with us this time is Aldo, one of our developers, and he's going to be talking to us about encryption. Hi, Aldo.
Hey, Lewis. How's it going?
It's going pretty good. I just wanted to give everyone a little background about you, just because you haven't been on yet. So if you just wanted to give me like a little, 2-minute spiel about your experience and what you do here at Arcane.
I hate talking about myself. But,
I'm going to make you for a little bit.
Well, I'm a developer here at Arcane. I've been a programmer probably since I was 15 or 16. Joined programming teams in school, was really into it. I'm largely self-taught. I've worked a lot extensively with all kinds of back-end technologies, Java, C++, C. Right now with Arcane, I work primarily with PHP, especially the Laravel framework, and we do a lot of client work here. So that's about as much as I can talk about myself there. So.
Oh, that's all right. I get it. I kind of can't stand doing it either. But as here always with us as well is Mike. How you doing, Mike?
I'm doing pretty well. Thank you very much.
And I just kind of wanted to preface this conversation with, I don't really know anything about encryption, so I'm going to be asking a lot of dumb questions here, but hopefully that'll bring up some insightful conversations. So I guess let's just get started with helping me out a little bit. How does encryption work? I kind of know a very little basic of it, but just anyone else that's listening that doesn't know anything about it, let's help them out too. So either one of you guys want to answer that one?
Well, it's a really broad topic, but just to be as simplistic as time allows, encryption started many centuries ago with what we would describe as Caesar encryption, and that's basically, back in ancient Rome, if Caesar wanted to communicate with someone in such a way that nobody would know what he was trying to say other than the intended recipient, he would sort of scramble up the message. And as a matter of fact, this is probably something many of you have done yourselves as kids without even realizing it, is if like you wanted to pass a note in class to your friend and you didn't want the teacher to read it out if they got it. You might say, you take the English alphabet and then you scramble letters around so that a B becomes an H, a C becomes a D, an X becomes an A, things like that, right? And then eventually have this code to be able to scramble your message so that it becomes garbage to any reader other than the other person that happens to know the same key that you used. Or not key, it's what we call a cipher. That's a very basic way of seeing how encryption works. That's what it is.
So that's a pretty simple way of putting it. So I guess kind of translating that to technology, how has encryption evolved from, shifting the alphabet around to computers talking to each other?
Well, so that's a good question. Obviously, with computers, we're not dealing with just the English alphabet or any alphabet anymore. We're dealing primarily with data. And data can be pretty much anything, right? So all data at the end of the day is just combinations of bits, zeros and ones. And the easiest way to encrypt something is to use an XOR logic operation on the data that you want to encrypt. Because the way that works is when you have a 1 or a 0, the XOR logic operation basically is asking, are the two bits that we're comparing a 1 or a 0, but not both? So if you put in a 0 and a 0, then the answer is 0. If you put in a 1 and a 1, then the answer is 0. If you put in a 1 or a 0, then a 1 and a 0, then the answer is 1. If you put in a 0 and a 1, the answer is 1. And the neat thing that this operation has is that it goes two ways. If you, let's say you have two numbers, 65 and 22, I'm actually not sure what the answer to that is off the top of my head, but let's say it's 87 or something like that. So if you do 65 XOR 22 and the answer is 87, you can take 87 and XOR it with 65 and you'll get 22, or you can get 87 XOR it with 22 and you'll get 65.
Also kind of like algebra.
So you're able to use this operation to encrypt data and to decrypt it back.
Oh, okay. I get that. So that kind of transitions to what's like the cutting edge of encryption, if you will. Like what is being practiced in business today?
Well, can I jump in here for a hot second?
Sure, go ahead.
I'd like to just make sure that we don't end up in a blockchain conversation.
That's fair.
That's the first thing I just want to say is, if you're talking about cutting edge technologies as far as encryption go, and I just want to make sure that we're not going down that particular path, but we should go back to that a little bit later, because there's just it's a pretty broad topic to go down,
yeah.
and in terms of application especially.
And setting scope is very important.
Yeah, so
we've been known to get off topic.
So I wanted to give Aldo a more pointed dialogue. I think it would be good to talk about encryption in login methods.
Well, so by login method, you mean the communication between client and server, or the actual password storage?
Password storage.
Well, in that case, we're generally talking more about hashing as opposed to encryption.
Right.
And the difference being that hashing is sort of like a form of encryption, except it's a one-way function. There's no way back, or there's not supposed to be a way back, so you can't decrypt.
Right. So that's I obviously led you to the conversation that we were having earlier intentionally.
Yeah.
So I just wanted to have that conversation because I think it's important that people understand that there are encryption methods that are intended to handle safer forms of communication. Like if you're encrypting a message, whether it's an email or if you're encrypting a credit card payment or something like that, with a merchant provider, or if you're using just a method of encryption that makes your website more secure, or just overall experience, whatever data you're transmitting, more secure, that is your encryption decryption method. Whereas what Aldo is referring to as far as hashing is concerned is really just taking a string, converting it into an obfuscated, garbled sort of string that has no meaning to it necessarily when you read it as a at
face value.
Face value. That's the word I was looking for. But in order to just sort of authenticate it and log in, for example, you would just use the same hash method against that string and compare it against the stored hash method of that same string in the past. You're basically just taking two of the same objects, or it could be different objects for that matter, or strings rather, and then hashing them and checking to see if they're the same. And if they're not, then you know that the original string that the hash was created off of is not the same when you're comparing the two. So that's a lot. I'd argue it's a form of encryption, but it's a form of encryption that has no way of being decrypted.
So could you kind of make the simplified version of that, saying like encryption can be dynamically used to save various things, whereas hashing's kind of just putting something through a specific filter, and if it comes out a certain way, you know that it's the correct form of that. Is that kind of an easy way to say?
the filter being like if A equals A, or if, really long.
Yeah, just some complicated function.
Right. Or a complicated string. Yeah.
String,
if two strings are the same, then the string, or the two hashes are the same, then the string that created the hash are the same. Otherwise, you know that they're not. So you're basically just doing a very simple. You would only be able to apply that for authentication. You wouldn't really be able to apply that for transmitting messages or anything like that.
Yeah, and that's kind of the point I'm trying to bring up.
Right. But interestingly, there are authentication methods that use base 64 encryption, which is a method of encryption.
Oh.
But
that's different than hashing.
It's sort of I don't know. Aldo, if you have any strong opinions about this, but I would say that base 64 is sort of like a rudimentary hash, or it's an encryption method that used to be used more commonly in authentication methods.
I would say it's more just because encryption has a sort of implication that the reason you're converting a message into garbage is to keep it secure, whereas when you run something through base 64, it's more just that you're just trying to make something safe to transmit. You're not really trying to hide it from anyone.
Right. So let's kind of just go back to Lou's previous question about more modern and widely used encryption methods, and I think one of the things to talk about, everyone obviously is familiar with SSL. Excuse me.
That's the one I am familiar with.
Right. And then there are different sort of like RSA encryption types that are associated with SSL. But there are also sorts of other encryption methods and protocols that are used for emailing and even like some of the, I guess you could refer to some of like the dark web communication chats and things like that. Before we dive into the previous conversation, which was, I guess, kind of leading towards blockchain, which is definitely where things are headed. I think a little bit too much. I think there's the blockchain craze is making people try to apply it for every damn thing imaginable, even when it's not necessarily applicable to.
I would say that it's starting to become synonymous, and whether or not it is or not, but people think it is. They think blockchain encryption just kind of tomato.
Oh, you think that it's just become commonplace to assume that one is the same?
Yeah, that one is the other.
I mean, people, that wouldn't surprise me, considering most people think that if you're a programmer, you know everything about hardware.
Exactly.
And vice versa. But I think it would be good for us to sort of dive into, before we talk about blockchain, just dive into a few other encryption methods. Or if anyone here has anything relatively new that they've heard about, I guess I'd open that up to, and anyone who wants to contribute.
Well, I, for one, am only familiar with SSL. So what else is out there, Aldo?
Well, actually, SSL is not really encryption in and of itself. It's more of a protocol, which we use for encrypting web communications. And actually, the latest form of that is TLS, which is really just they sort of renamed it, but it's still based on SSL. It's more like SSL version 3 or 4 or something like that. I forget. But so
I think it's 3.
Yeah, something like that. So basically, SSL is just the protocol that we use on web technologies for encrypting messages between a client and server securely. And it's based on a few things. So the encryption itself is typically RSA, which creates 2 keys used for encryption and decryption. both keys can be used for either encryption or decryption, but the way that it works is that if you encrypt something with one key, then the only way to decrypt it is with the other key. So if you have key A and you encrypt something, key A will not be able to decrypt it. And that provides some benefits. For example, first, before I start talking about the benefits, the way that you would use those two keys is that you have a private key that you keep for yourself that you never share with anyone. And then you have a public key, which you publish it. Anyone can get it. Anyone can use that key. And then the benefits of that are that if you send someone a piece of data that's encrypted with your private key, and that person is able to decrypt it with your public key, then it means that you have to have been the sender, because that public key can only decrypt messages created with your private key, which everyone would know that only you have. So if I was able to decrypt a message with your public key, then you are definitely the person that sent it, which is good to know, right? You don't want to, like if you're putting your credit card information onto a website, you don't want to be putting it into someone that's pretending to be you as opposed to actually you. Second of all, it provides a way for people to encrypt messages and talk to each other in a way that we know that someone listening in, a third party listening into the communication, won't be able to interact with. For example, usually the way it works is that there's a handshake, which provides the client with their set of keys. So when the client is communicating with a server, the client will use your public key to encrypt the message, and nobody will be able to decrypt that message because only you have the private key. So the client will know that their message is not going to be able to be decrypted by anyone other than you, because they used their public key. Then, since during that handshake, the client sent the server their public key, the server will also be able to use your public key to encrypt something and send it back to you to make sure that only you can decrypt it. And that's basically the way these asymmetric keys, key encryption works.
Bravo. Well done. Good explanation. Yeah. I mean, that pretty much says it all. I mean, there are definitely a whole bunch of different methods out there outside of just RSA, but that's probably the most commonly used. I know AES is more commonly used in government authentication methods.
Well, AES is symmetric encryption, if I'm not mistaken. So it's not. It doesn't apply. It doesn't work by those same principles.
Right. Yeah. It's. I think it's symmetric.
A symmetric encryption is when you have just one key. So, like for example, if you're using WinRAR to compress a bunch of files into one compressed file, and you put a password onto it, it's using AES encryption.
DES is symmetric as well, isn't it?
Yes, it's the old standard that the U.S. government used. It was originally, if I'm not mistaken, designed by an IBM engineer and adopted by the government in the 70s. And then a couple of Belgian cryptographers, I think in the 90s or something like that, late 90s.
Yes, is late 90s. Yeah.
Came up with AES and submitted it to the NIST, and then the U.S. government adopted AES.
Yeah, that's cool.
So it seems like there's lots of different options out there. Yeah.
So there's basically whether or not you want to use asymmetric or symmetric encryption, but for the most part, there's the standard AES or the standard RSA for asymmetric. You don't want to go with any older technology. Yeah. There are some unpatented encryption technologies like Blowfish come to mind. But for the most part, most people are using AES for symmetric or RSA for asymmetric encryption.
Yeah, there's two fish as well, I think, right? There's Blowfish.
Yeah, two fish is another one that's unpatented.
That's interesting. The naming that like that, just Blowfish, and then we're just gonna call this. It's the second one, all right? Two fish. All right, sounds good. That's very.
Not sure they're related.
Kind of a random thought that I had, but like, is encryption one of the? I guess one of the only is probably a really broad statement, but I'm going to say it anyway. So is encryption one of the only areas of technology where you don't see people branching off or using older versions of a system because of whatever reason, like, WordPress, you need certain versions of plugins to work with other versions of plugins, or like Oracle, like people build custom parts of Oracle just for their own business, so they only use, this one part of Oracle. So like, is encryption this one area where like everyone needs to be up to date at all times? Is there any other area of technology that's like that?
Yeah, I mean, I guess it's kind of a bit of both. Everyone should be up to date, and for the most part, if you've got security issues, your whatever software, whatever hosting provider, whatever operating system you're running is going to be trying to make you put those patches into place with whatever encryption methods that they require. But there's usually like a graceful degradation period for things like, just to go back to SSL for a moment, for things like SSL, for example, they'll give you like a period of time to start complying with the new technology before they completely phase out the old one. But there are definitely like, you're technically not like required to use a certain encryption method. It's really just a trust factor. People will know whether or not you're using the right type of encryption method, or if you're using, like if you're not using RSA and you're not, if as an example, let's say you're using like password authentication on a login for a server, or if you're using an outdated SSL encryption method, or you don't have an SSL, or I should say RSA encryption method on SSL, or if you don't have an SSL installed at all, everyone's going to know. So there's a trust factor involved there. But as far as like,
if you've ever gone on a website and you see like an unlocked red padlock or something along those lines, that's telling you that either the website's not encrypted at all, or rather the communication between you and the website is not encrypted at all, or their encryption is not, it's outdated. So like if someone's using SSL1, I'm pretty sure most browsers, or at least Chrome, will show a degraded experience message to let you know that they're not using the most up-to-date encryption, assuming they're using any at all.
Right. Your browser will also notify you if there are like any elements of the base, even if you have like the right SSL installed and configured and everything, and there are elements of it. It could just be like images or, any sort of like remotely hosted CDN that you're referencing in your DOM structure anywhere. It'll notify you that that's not encrypted if it's a non like HTTPS URL, or even if it's an invalid SSL that you're pulling from.
It'll also give you a warning if someone is pretending. So if you go on if you think you're on Google but you're actually not, it'll tell you.
Yeah.
Because of what I told you earlier.
And they also have like different validation methods. There's something called extended validation. The actual encryption method, it's the same across those different validation methods for modern SSL, but they have different sort of like trust values that are associated with it. So the person that they purchase it from, I don't think VeriSign is like a thing anymore. It's like owned. Which one is it? Thought was bought by VeriSign, or VeriSign was bought by Thought? I don't remember. But like, suppose you're buying.
I've never purchased an SSL certificate in my life.
Yeah, you don't have to purchase them.
Yeah,
most of our.
You used to be able to. I mean, you used to have to purchase them if you wanted SSL on your website. They're you can generally get them for free nowadays. But if you want like the super big, like this is definitely who you want SSL certificates, I think you still do have to pay for those.
Yeah.
Because those give you also a like a background check and
Yep.
on your business and whatnot, which provides extra confidence to the customer. So
Right.
yeah, but for the most part, most sites just get a free SSL certificate. I think Let's Encrypt is probably the best place to get them nowadays.
Is Let's Encrypt. But like that's exactly what Aldo is talking about. Mm-hmm. That's an extended validation. That it's an actual human check. They do background checks and stuff like that. But the encryption method's the same. But yeah, it ultimately it's a trust thing. But like if you wanted to actually just say, hey, I want to use like a alphanumeric coder or like a Caesar cipher or something like that to do something, no one's stopping you from doing it. You're just
exposed.
Yeah. So I wouldn't suggest that anyone would do that. But so to your question, there are definitely legacy systems that still exist out there, and we encounter them daily. But the world is just kind of slowly pushing those people out by making it so that everyone else knows when they're not in compliance with modern standards.
And also by providing modern standards for free. Whereas, I mean, I remember some of my first websites, I was like, wow, I really wish I could have these, secure, but I'm not paying for that. I'm broke.
Yeah, that's a very good point.
Right. But now anyone, no matter their budget, if you just want to have your own little blog and you want it to be secure, you can do it for free now.
So to Aldo's point, there was like I don't know the exact date, but like, I don't know, I would say it was probably about like 8-9 years ago. There was a transition from most websites at the beginning of my career were just HTTP. Mm-hmm. You were not really required to have an SSL, and if you did, it was really only if you had like.
You're
really
still not required to have an SSL. It's just that
you're not right
now. It's default behavior that the browser will warn users. Whereas before, it used to be that the browser would not show anything and show you a positive message if you were secured. Whereas now it's the other way around. It doesn't show anything nowadays, and it shows a negative message if you're not secured.
Right. But in addition to that, you'll also be your Google rankings are impacted. So Google had this algorithm, this Penguin update, where they really started trying to go more for trust value. So that's when a lot of things changed, where like instead of going for a quantity of backlinks and density of keyword density, it was really more about quality of content and quality of backlinks. So it wasn't really about quantity as much as it was about quality now. And with that came a lot of these sort of standard practices of you have to have an SSL on all pages. Even when there was like you would have SSL for PCI compliance or whatever. A lot of those websites 10 years ago didn't even have it on all pages. It was like strictly on checkout and login or registration.
Yeah.
It wasn't, but now it's just like all pages, www subdomain, that's the standard. And that's largely, like Aldo said, it's not required. I mean, there's not very little that you're required to do, but the powers that be, and Google being one of them, make it very difficult for you to go about your business unless you're following those standard practices.
And the consumer.
That's a good thing. It has made the web a lot more secure for the end user at the end of the day. So it's a good thing.
Yeah, I agree.
Oh yeah, that's interesting. But we're getting there on time, so I just kind of wanted to say thanks to Aldo for joining us on this talk about encryption. You said earlier that you didn't seem like you thought you were an expert in it, but I mean, everything you just said, it seemed like you were pretty well versed in it all to me. I mean,
this is all surface knowledge. It goes way deeper than anything we've talked about today. I'm definitely no expert by any measure of the word.
Yeah, well, I mean, the conversations that we had with Matt in particular, I think, started very much like these, where we're really talking about things that we at least know, and then the second half, we're getting into things that we're completely unqualified to be discussing. Complete speculation. Yeah. So, thanks a lot, Aldo. Really appreciate your time, man.
Yeah, we'll have you on again.
Yeah, no problem.
We'll definitely have you on again. But anyone listening, thanks for listening in, and we'll be back next Wednesday at 2:30. Next Wednesday at 2:30 Eastern Time for our live Q&A. If you have any questions about this podcast or any of the other ones, it's a good time to ask because we'll be able to answer them right then and there. So thanks, everybody. Thanks, Aldo. Thank you, Mike.
Yep. Have a great day.
Thanks for having me. Bye.